Hello students, welcome to online maths classroom. In this video, we will learn about solutions of miscellaneous exercise of topic application of derivatives. So let us start with it. Using differentials, find the approximate value of each of the following. Now, as we know, this topic has been deleted, but let us go through it also as it is very interesting. So this is your 17 by 81 raised to power 1 by 4. So what do? We pick up a function y which is of this form. Okay, so that is, it is of the form of x raised to power 1 by 4, and this is of the form x raised to power minus 1 upon 5. So y is your x raised to power 1 by 4. So dy by dx is your 1 upon 4x raised to power 3 by 4, right? So dy is your dx, take this to other side, dx upon this 4x raised to power 3 by 4. Okay, and which can be written as x raised to power 1 by 4 whole cube, which is approximately delta x upon this complete thing. Now change x to x plus delta x and y to y plus delta y. So y plus delta y is your x plus delta x raised to power this from here. Okay, y plus delta y equal to x plus delta x raised to power 1 by 4. So this becomes 16 by 81 plus 1 upon 81 raised to power 1 by 4. Here you have to break in such a form so that you can easily take it out of the fourth root bracket. Okay, so 16 by 81 and the plus 1 upon 81 will be served as delta x. Okay, so comparing it with it, you will get x is this and delta x is this. Now x raised to power 1 by 4, you see it is 2 by 3. That's why we split it like this. Okay, now this can be written as y plus delta y, which is your y is this and delta y is this. Okay, now putting the values back here, it becomes 2 by 3. Okay, from here plus 1 upon 8. Put all the values and after calculation you will find it is turning out to be 0.677. Similarly, for this, y is x raised to power minus 1 by 5, the derivative. Okay, dy can be written as minus delta x upon this. Now y plus delta y change to x plus delta x. So this is like this. So to take it out of the fifth root, I should take x as 32. So it is your like this, 2 raised to power minus 1, that is 1 by 2. Right? So after applying the same result, changing it to y plus delta y form, putting up all the values, I'll get that it turns out to be 0.497. Okay. So question number 2 is show that function given by fx equal to log x upon x has maximum at x equal to e. So you know for maximum what should I do? That I will check the function here existing for x positive, as you know that it will be your, if it is 0 it is not defined, and even for taking log to exist this should be positive. So this is the derivative, double derivative is this. Okay, critical point is 1 minus log x equal to 0 log x1, that is which is at log e, so x is equal to e. I'll check the second derivative. Okay, so which turns out to be negative, that means x equal to e is the point of local maxima and fx has a maximum value at x equal to e. Now this is a very important question. The two equal sides of an isosceles triangle with fixed base b are decreasing at the rate of 3 cm per second. Okay, the question of rate measure. How fast is the area decreasing when the two equal sides are equal to the base? So these are the two equal sides x and x, and this is the base. Okay, now if it is say b, so you know that when we'll draw perpendicular in an isosceles triangle, it will be b by 2, b by 2. Okay, so fixed base is your b, and given here dx upon dt means the equal sides are decreasing at the rate of 3 cm per second. So you know decrease means dx by dt is minus 3 cm per second. Okay, and this bm and cm, you know it very well, the perpendicular serves as your bisector also. So it is half of b. Now area of triangle is half into base into height, bc into em. Okay, so bc is your, this basis using Pythagoras theorem you can apply. Okay, and putting all the values you will get it like this. Right, now I have to differentiate it. Okay, so the derivative is turning out to be this. derivative is turning out to be this. Now when the two equal sides are equal to the base, okay, that is x equal to b, this is equal sides are equal to the base. So check the derivative, okay, this derivative you find it is negative, that means it is decreasing. So area is decreasing at the rate of 3 root 3b centimeter square per second. Find the equation of normal to curve. So y square equal to 4x is a parabola, right-handed one, at the point 1, 2. So point 1, 2 is somewhere. Okay. So this is the parabola. Differentiate. Okay. 2y dy by dx equal to 4. So dy by dx is 2 by y. Now slope of the tangent at this point will be the value of the derivative. Okay. So that is turning out to be 1. Okay. Value of the derivative at 1. So 2 by 2 as x is not there, so it is 1. And slope of normal is minus times negative reciprocal of this. So it is minus 1. Equation of normal by passing through this and having slope, this is y minus y1 equal to m2 minus m times x minus x1. So m is here this, and this is x1 y1. So equation is x plus y equal to 3. Show that normal at point theta to the curve x is equal to and y equal to is at a constant distance from origin. So you know I'll be applying the parametric form result firstly. So this is, I will obtain first dx by d theta, dy by d theta, and dy by dx by dividing them, which turns out to be tan theta. And slope of tangent at point xy, right, that will be given by your tan theta. Okay. So what is the slope of normal? That is minus 1 upon this tan theta, that is minus cot theta or minus cos upon sine. Now equation of normal at the point is given by, or these are the points. Okay, this is y minus y1 equal to the slope of normal x minus x1. So when you will open it, you will get some equation like this. Okay, this is either this or it is this one. Okay, means if you bring it to, because you know when you have to apply the perpendicular distance formula, you have to take the constant to other side. So this can be expressed like minus a equal to 0. Now perpendicular distance from origin, the formula is ax1 plus by1 plus c mod upon under root a square plus b square. This you have done in your class 11. Okay, so apply it. This becomes 0, x1 y1 are 0, these 2 points, and c is your minus a from here. Okay, c is minus a upon under root cos square theta, a square and b square, that is cos theta sin square theta, and which turns out to be a as it is 1, which is constant. Find the intervals in which the function is increasing or decreasing. For increasing decreasing function, I should go for the derivative first. Okay. Now see from here, see there is something to observe, that if you break from here, means I take x common, it can be splitted in simple form and the function will be just like this. So instead of going for this quotient rule to complete term, which will increase the length of the question, it's better to understand to split it. Okay. Use quotient rule to this side, take LCM. Okay. And we have done such type of question in your main exercise of increasing decreasing function also. So I'll get it as 4 cos x minus cos square x upon 2 plus cos x whole square. Take cos x common, it is 4 minus cos x, and this is 2 plus cos x whole square. Okay. Now you know the value of cos lies between only minus 1 and 1. So 4 minus cos x will be positive, because 4 minus 1 or 4 plus 1 will always be positive, and denominator is itself 2 plus cos x whole square, it is always positive. So everything depends upon this cos x outside, right? So function is increasing if the derivative, first derivative is positive, greater than equal to 0. That means if cos x is greater than equal to 0, means either x is lying in first or fourth quadrant, because here cos is positive. So function is increasing in 0 to pi by 2 or 3 pi by 2 to 2 pi, that is the fourth quadrant, and will be decreasing if this function is negative. So it is negative in second and third, that is decreasing from pi by 2 to second and third can be together taken as from this pi by 2 to 3 pi by 2. This complete. Okay. Next is number 7. Find the intervals in which the function divided by this is increasing, decreasing. So again start with, I have to find the points here also. So this is the function. This is the derivative. Okay. So the step is, this is my function. I should just, using the formula, I should factorize it properly. Okay. Then I can go for making the intervals. I'll find the critical point first. So my critical points are coming out to be -1 and 1. Okay, so two critical points I will get. I'll divide it in 3 intervals, that is -infinity to -1, -1 to 1, and 1 to infinity. Okay, so see from here, I'll check my derivative at these points. So take a point here, say you can start with -2 like this. Check the derivative, it is positive, this is negative. Okay, and as it is splitted in this form, and the overall result is your positive. Okay, so it is increasing. Okay, -1 and 1 you should take half. Avoid taking 0, it will turn out to be negative, so it is decreasing. And for 1 to infinity, that is, let's see, 2, it's all positive, so that is increasing. So it is increasing for less than equal to -1 and for x greater than equal to 1, and decreasing for -1 to 1. Find the area of isosceles triangle inscribed in the ellipse where the vertex at one end of the major axis. So see the picture of ellipse, right? So here is an isosceles triangle. Vertex at is here with its vertex at end point of major axis. So this is the major axis, right? So this is this kind of ellipse you can see from the equation. Okay. Now this is your A0 as the length is 2a. This is minus A0. This is A0. Okay. So this is your, take it, join from here, right? So you know that the extremities of the major axis of the ellipse are A0 and minus A0. Okay. So these are the positions made from this. Now comparing the equation with cos square theta plus sin square theta equal to 1. We have x upon a equal to cos theta. Okay. From here, like x upon a is equal to cos theta, as it is of the form cos square theta plus sin square theta equal to 1. So cos theta is x upon a and sin theta is y upon b. So x is a cos theta, y is b sin theta. So it is a cos theta and b sin theta. So this point is having this coordinate, and this point as y is negative towards this axis, this side. Okay. Now draw PM perpendicular and produce it to meet the ellipse at Q. PM is equal to QM. So this is how we can make a coordinate. Okay. Now this M is the midpoint of PQ. That means my APQ is an isosceles triangle, and Z is denoting the area. Area is half into base into height, that is half into PQ into MA. Okay, AM or MA. And this PQ can be taken as 2 times PM, we can take it as, okay, as it is symmetrical to both sides. And AM can be written as OA, this OA minus OM. Okay. So I have to change the complete into form of sine cos. So you know it is PM is your B sin theta. Okay, B sin theta. This is y coordinate, B sin theta. It is A minus A cos theta. Open it. Okay, right? So Z is your this complete expression, change to sine cos, and dz by d theta. Second derivative. Okay, to find critical point, put 0. We get theta is either 2 theta or 360 minus 2 theta. That is either it is 0 or it is 120. But 0 is impossible, as in this case it will be, the coordinates will be A0, which will be coinciding with point A. So theta is 120. So when theta is 120, the second derivative is turning negative. That means area is maximum, and maximum area you can calculate by putting it in the angle theta is 120 in your area expression. So it turns out to be 3√3 AB. Number 9 is a tank with rectangular base and rectangular sides open at the top is to be constructed so that its depth is 2 meter. Okay, volume is 8 meter cube. If building of tank costs ₹70 per square meter for the base, 45 square meter for side, what is the cost of least expensive tank? So as this tank is rectangular base and rectangular sides, okay, that imagine it as a room which is not having only walls but floor. Okay, floor is there, walls is there, but there is no ceiling. So depth is this. So x meter is the length, y meter is the breadth. So volume is LBH. So it's like given as 8 meter cube. So that means your xy into 2 is this. So y is 8 by 2x, that is 4 by x. Now let us start with the cost function. So cost function is your rupees 70xy. Okay. Now again cost of building the 4 walls. This is for your base. Base is a rectangle. Now 4 walls, area of 4 walls is your, you have to take like, okay, 4 walls, the cost of it will be 45 times the 4 walls. Okay, area of 4 walls. So that is 45 into 4x plus 4y. So if you will put the values of x and y, you will get it as 180x plus 180y. So if z is the total cost of the building, so it will be including your the amount which is costing for the floor and for the 4 walls. So this is 70xy plus 180x plus 180. Now put y equal to 4 by x to change it to single function, as this is the only possibility. Okay. Now dz by dx, second derivative. This is critical point, turning out to be true. Okay. Derivative is turning out to be positive. Z is minimum cost. You can calculate by placing x and y in your z, which is rupees 1000. Number 10 is the sum of perimeter of a circle and square is k. So this is a circle with radius x and the square, okay, with side y, right? So sum of perimeter, you know, it is 2 pi r and it is 4 into side. So 2 pi x plus 4y equal to k. From here calculate y. You have to prove sum of their areas is least. So area will be your pi x square plus y square. So to prove it least, again start with, this is your z. Okay. Open it, change using this y completely to x. This is your z, dz by dx, second derivative. Okay, critical point by putting equal to 0, k upon 2 into 4 plus 5, right? And the derivative is turning out to be positive, that means it is minimum, right? Now I will put it in y. So all the values will give me your 2 times this completely, k upon 4 plus pi, which is your 2 times k upon 2 into 4 plus pi. That means y equal to 2x. So sum of area is minimum when side of the square is double the radius of circle. Okay. That's another important question. Window is in the form of a rectangle surmounted by a semicircular opening. Okay. Total perimeter of the window. Total perimeter means, see, total perimeter will be this perimeter of this semicircle and the 3 sides, not the 4 sides, as this 4 side is included with this. So it will be like the semicircular portion, okay, that is half of 2 pi r, half of this perimeter of circle plus the length AD plus DC plus BC. Okay, this complete is equal to 10, and it is, instead of taking it as x or y, it's better to take it as 2x, as I have to do it half. So instead of carrying out fraction, it's better you take it as twice so that it is x, and it is okay with to go for y this side. So from here I'll calculate y is this. Okay, now z is the area of window. In area will be your area of semicircle plus area of rectangle. Okay, so see carefully that the one side is 2x and other is y, so that is length into breadth. Now use that y value to change this complete question in terms of x. Now dz by dx, second derivative, critical point, turning out to be 10 upon 4 plus pi, and the derivative turns out to be negative, means it is maximum. Okay, the value of x will give me the value of y. Okay, so length of rectangle is 2 times x, that is 20 by this, width will be y, and radius of semicircle is again x. Next question is, a point is on the hypotenuse of a triangle at a distance of a and b from the sides of triangle. So this is a point in a right triangle, and this is at a distance of a and b from the sides of the triangle. You have to show that minimum length of the hypotenuse is, so we are talking about the length of this hypotenuse. So length will be taken as AP and PC. Okay, so these are same, these are the corresponding angles, this one and this one, right? So in right triangle, this APL, I apply this AP upon AL will be cosecant theta. AL, okay, AL, right? This AP will be taken as PL cosecant theta. Take it to other side. And PL here is your A. So it becomes A cosecant theta. Similarly in PMC, this PC becomes B secant theta. So total length becomes A cosecant theta plus B secant theta. Theta lies between 0 and 90. So first derivative, put it equal to 0 to get the critical point. And critical point is your tan theta is, it becomes tan cube theta equal to A upon B. So tan theta is A upon B raised to power 1 by 3. Right? Now the second derivative, d square z upon d theta square. Right? It is your, becomes, it's you have to apply the product rule here also. So it's a large term and you have to rearrange it like this. Right? So as AB both positive, right, between 90. So the derivative, because we need not check it, we can just interpret it from here that as it's the case of first quadrant, so second derivative will be positive, so z will be least when tan theta is this. And you know secant square theta is 1 plus tan square theta, so it is 1 plus this, and by taking the LCM, b2 by 3 plus a2 by 3 upon b raised to power. So secant theta is your a2 by 3 plus b2 by 3 upon b1 by 3, and this whole, this top raised to power 1 by 2. And cosecant square theta is 1 plus cot square theta, which can be calculated like this. Right? So minimum length of the hypotenuse is your a cosecant theta plus b secant theta. Put all the values of cosecant and secant from here, and after taking LCM and arranging, it becomes a2 by 3 plus b2 by 3 raised to power 3 by 2. Okay, so you can see from here that how we have taken secant and cosecant. Find the points at which the function given by f is equal to this has local maximum, local minimum, and point of inflection. So for local maximum minimum, let us start with function, the derivative. Okay, form the factors to get the critical point. F dash x equal to 0. I'll get x as 2 minus 1 and 2 by 7. Okay, so we are going to check it by first derivative. So for x equal to 2, when x is less than 2, when say like 1.9, so f dash x turns out to be negative. For greater than 2, like 2.1, it turns out to be positive. So something from negative to positive, that means it is minimum. At x equal to minus 1, for less than minus 1, like say minus 1.1 like this, this turns out to be positive. And for greater than minus 1, it turns out to be positive. Okay, so from positive to positive. Okay, no change from positive to positive. So such point is called as no change, means the point of inflection. So minus 1 is the point of inflection. And at 2 by 7, for less than 2 by 7, derivative is positive. For greater means it is negative. So from positive to negative, again the case of local maximum. Number 14 is function is there. You have to check the absolute maximum and minima in 0 to pi. So start with function, the derivative, the critical point. You get sin x as half. Okay, x is half and positive, and it is lying in first and second quadrant. So I'll get, because it is, we have to cover all the angles between 0 and pi, so I'll cover both angles pi by 6 and 5 pi by 6. Okay, so turning points will become like my pi by 2, pi by 6 and 5 pi by 6. Okay, because all of them are belonging to 0 to pi. Now I will check my f of pi by 2, f of pi by 6, f of 5 pi by 6, f of 0, f of pi, all. Right? And from here I'll get my values that the absolute maximum is 5 by 4 and the minimum is 1. Okay, it is 5 by 4 and it is 1. Okay, show that the altitude of right circular cone of maximum volume that can be inscribed in a sphere of radius r is 4r by 3. Again the case of cone inscribed in a sphere. Okay, so this is the, see, small, here a different question was there in which the capital R was taken as the radius. So here it is small r, so don't get confused. So we are taking the base radius as x, so it again becomes r. Okay, so you have to take the height of the cone as complete y. Okay, so this becomes y minus this small r. So apply Pythagoras theorem, y minus r whole square plus x square equal to r square. So convert same way, x square is 2ry minus y square, and the volume is this, converted to complete y term. Then dv by dy, the second derivative, the critical point 4r by 3. This turns out to be negative. Volume is maximum when y is 4r by 3. Let f is a function defined on AB such that first derivative is 0 for all x belonging to AB, then prove that f is an increasing function on AB. Okay, so this is actually, this question can be done by using LMBT. Okay, so let your interval is AB, we denoted by I, and this is positive. Okay, that means for x1, x2 belong to I with x1 less than x2, means point x1 is smaller than x2, right? The derivability implies continuity, means if the function is differentiable, it is continuous. Okay, the fx is continuous in closed interval x1, x2, and it is always differentiable in open interval x1, x2. So LMVT says that fx2 minus fx1 upon x2 minus x1 is f dash c. Okay, where c is a point lying between this x1 and x2. Okay, right? And this fx2 minus fx1 is equal to, take it to other side, x2 minus x1 times f dash c. Now if x1 is less than x2, okay, that means x2 minus x1 is greater than 0. Simple. Bring it to this side and arranging, you get x2 minus x1 is greater than 0. Right? So that means what happens? Also, f dash x is greater than 0 for all x in I. That means f dash c is positive. Right? So I get that fx2 minus fx1 is positive, or I see fx2 is greater than f of x1, or f of x1 is less than f of x2, one and the same thing. So what do I get? That for the pairs x1, x2 belonging to I, where x1 was less than x2, I got f of x1 less than f of x2. And this is the example of strictly increasing function. Okay, right? So we can see from here also, right? The graph of strictly increasing function is a rising graph and it moves upwards, and the reverse function, that is decreasing function, is in this way. So this is how we can always interpret it like this, that slope of tangent is positive, right? Then derivative is positive, and if it is negative, then it is, your function is decreasing. Number 17 is, show that height of cylinder of maximum volume that can be inscribed in a sphere of radius r is 2r by root 3. So this is, now this is cylinder is inscribed in it. So this is the radius of the sphere, this is the radius of this cylinder, y is the height. So as it is symmetrical, so this is y by 2, y by 2. So apply the Pythagoras theorem, I'll get x square plus y by 2 whole square equal to r square. So x square, get the value of x square. Now volume is pi r square h. Okay, convert using this to one variable y. dv by dy, second derivative, critical point turns out to be r square equal to this. Okay, and y square is 4r square by 3. Okay, or y is 2r by root 3. Second derivative turns out to be negative, means volume is maximum at this value. Okay, and the maximum volume we can calculate by putting it in the volume of cylinder. Okay, changing to 4 pi r cube by 3 root 3. Show that height of cylinder of greatest volume that can be inscribed in a right circular cone of height h and having semi-vertical angle alpha is 1/3 of that of cone, and the greatest volume of the cylinder is 4 by 27 times pi h cube tan square alpha. So there is a cone whose radius is r. Okay, radius is r, and the height of this cone is h. In it, a cylinder is inscribed whose height is y and radius is x, and this is the semi-vertical angle. So I need to prove that this height of the cylinder is 1/3 of that of height of cone, that is y is 1/3 of h. Okay, so let us start with it. As you can see from here is that this triangle ARC, look at this triangle ARC. This triangle ARC is similar to this triangle APQ. Okay, this triangle APQ. This is similar to this triangle APQ. Both are right triangles. Now, by the concept of similar triangles, this PQ upon RC is equal to AP upon AR. Okay, Now what is AP? This complete is H and it is Y. So AP is my H minus Y. Okay. So PQ upon RC is equal to this my AP upon AR. So I get X upon R equal to H minus Y upon H. From here I'll get the value of Y. Now the volume of cylinder is Z is equal to pi X square Y. Okay. So replace the value of Y so as this complete set can be changed in terms of X. dz by dx, d square by z dx square. To find critical point, put dz by dx equal to 0. I get the critical point as x is equal to 2r by 3. Okay. Now second derivative is negative at this point. So z is maximum when your x is 2 by 3. When x is 2 by 3, y is h by 3. So this is the condition that your height of cylinder is 1/3 of height of cone. And the maximum volume of cylinder, from here, this expression, change everything in terms of your r. Because you see, I just need this pi, h cube and 10 square alpha. So I'll change everything in terms of h. Okay. So what I need to do is, I'll put the values of x and y is not required here, but the values of x. So in that way, I'll get from here pi hr square and it is your 4 by 27. Okay. Now in triangle ARC, this big triangle ARC, what is tan? Tan is your perpendicular upon base, that is r upon h. So r upon h is tan alpha, r is equal to h tan alpha. So from here I can put h tan alpha whole square. So it is 4 by 27 times pi as h square and h pi h cube tan square alpha. Now question number 19. Choose the correct answer in the exercises from 19 to 24. So a cylindrical tank of radius 10 meter is being filled with wheat at the rate of 314 cubic meter per hour. Okay. Then the depth of the wheat is increasing at the rate of. Okay. So again, this is a question of derivative as rate measure. So let y meter be the depth of the tank of wheat in the cylindrical tank of radius 10 meter at the time t. Okay. Now v is the volume of the wheat in cylindrical tank. So this is your pi r square h. So this is your y, this is radius. So pi r square h gives me 100 pi y cubic meter. Okay. Now given rate of increase, that means dv by dt is, this cubic meter means it is rate of change of volume, that is dv by dt is 314. Now differentiate it, this function, I'll get it as 100 pi y, okay, by 1, this is equal to 314. Okay, so it is 100 pi and dy by dt. This is how to differentiate it, equal to 314 using pi as 22 by 7, okay, or 3.14. I'll get the value of dy by dt as 314. Okay, so this is your, after cancellation, I'll get my y as 1 meter per hour. Okay, as 314 y is equal to 314. 100 multiplied with 3.14 will give me 314 y. Okay, and from here I'll get y as 1 meter per hour. So here the option A is the correct answer. The slope of tangent to the curve, x is this, y is this. So definitely it is a parametric form at 2 minus 1. So equation is x is equal to this, y equal to this. To get dy by dx, I need dx by dt, dy by dt and dy by dx. We can obtain by dividing dy by dt by dx by dt. Okay. So at the point 2 minus 1, I have to check my slope of tangent to the curve at this point 2 and minus 1. Okay. So I'll put first x equal to 2 here, right? So I'll get t as minus 5 and t2, and to this side when I'll put y as minus 1, in this equation I'll get t2 as minus 1. So common value of t will be your t equal to 2. So at the given point 2 minus 1, t is 2. So putting t equal to 2 in 3, this number 3. Okay. what I will do is, I'll at point 2 minus 1, my slope will be 6 by 7, which is my option number B. The line y equal to mx plus 1 is tangent to the curve if the value of m is. Okay, so this is my parabola, right-handed parabola, and this is the line. Okay, so you know that I will find the slope of tangent. So this is my curve. I'll find dy by dx by differentiate 2 by y. Slope of tangent at xy will be 2 upon y. Okay, which is your m, right? Because the slope of line is same, right? Because he says that this y equal to mx plus 1 is the same tangent. So slope is same. So from here I'll get y as 2 by m. Now I have to eliminate x and y from 1, 2 and 3. This is my equation number 1. Okay, and from equation number 2 and from this 2 and from 3. So I'll put y equal to 2 by m. Okay, I'll get x as 2 minus m by m. So putting the values of x and y from number 4 in and 3 in equation number 1, I'll get 4 by m square equal to 4 times 2 minus m by m square, and on dividing both sides I'll get m as 1. So my option number A is correct. The normal at point 1, 1 on the curve is, I have to check the equation. So equation of the given curve is this. Differentiating, I'll get dy by dx equal to minus x. Slope of tangent at 1, 1 will be my minus 1, which is my m. Okay, slope of normal is negative reciprocal, so it is 1, and I can check that the normal at the point will be, like I can check it turns out to be either minus x plus y equal to 0 or x minus y equal to 0. Okay, so option number B is the correct answer. The normal to the curve, okay, this is a parabola passing through the point 1, 2, is the normal to the curve passing through the point, passing through the point 1, 2. The normal to this curve, okay, this is the tangent, this is the normal which is passing through 1, 2, right? Now let the normal to the curve at pxy pass through the point a, 1, 2. So I'll first differentiate. Dy by dx is x by 2. Slope of normal will be minus times negative reciprocal, that is minus 2 by x. Slope of normal also using this 2-point form will be y2 minus y1 upon x2 minus x1. So it is like this. Both are same. From here I'll get y equal to 2 by x. Okay, and y equal to 2 by x I can put in my equation x square equal to 8 by x. So I'll get y as 1 and x as 2. So 0.21 will be there. Slope of normal is minus 1. Get back here. Okay, as x is your 2, then y is your slope of normal will be minus 1, right? So equation of normal is y minus y1 equal to m times x minus x1, and the equation turns out to be x plus y equal to 3. So option number A is the correct answer. X plus y equal to 3. Question number 24. The point on the curve 9y square equal to x square, where normal to the curve makes equal intercept with axis. So this is your equation. Find the derivative, right? Slope of tangent to the curve at point xy will be x square by 6y. Slope of normal is negative reciprocal minus 6 upon x square, which is equal to plus minus 1. Okay, because the slope of line making equal intercepts on the axis are plus minus 1. So this is clear. We have done a question in class plus 1 also. So minus 6y is equal to plus minus x square. So here y is minus x square by 6. So solving 1 and 2, I'll get y as this. Okay, and x on comparison, x4 equal to 4x cube, I'll get x as 4 after cancellation. So x is 4, y is minus 8 by 3. So this is the required point. Okay, and if I take the negative sign, the required point will be 4 plus minus root 8 by 3. So option number A is the. I hope whatever is taught to you, give a good practice to it. Practice as many questions you can do. Okay, and just be particular that sometimes using second derivative test is more convenient. Sometimes first derivative test using will reduce the calculative process of the question. So if you feel that what means this is the technique, which particular method you should, unless until it is you should go for a suitable method so that you can do the questions with not committing errors. Okay, so thank you so much.